करारविंदे तु पदारविंदम मुखारविंदे विनिवेशयन्तं वटस्य पट्टस्य पुटे शयानं बालं मुकुंदम मनसा स्मरामि। सो भगवान परमेश्वर को प्रार्थना करते हुए और माँ सरस्वती को वंदना करते हुए आज के इस कार्यक्रम का हम शुभारंभ करने जा रहे हैं। आदरणीय हरिप्रसाद जी बुधिया, आदरणीय श्रीमती डॉक्टर अन्नपूर्णा जी, हमारे प्रिय मित्र और विश्व प्रसिद्ध एस्ट्रोफिजिसिस्ट डॉक्टर देवी प्रसाद दुआरी जी, सभा में उपस्थित मित्रों, साइंस एंड सोसाइटी सिम्बायोसिस का इस सत्र में आप सबका मैं हृदय से स्वागत करता हूँ। विचार मन में आया था कि समाज और वैज्ञानिकों के बीच के अंदर एक दूरी सी बनती जा रही है। हम वो क्या कर रहे हैं, कितना सम्मान तो हम उनका करते हैं मन ही मन, लेकिन दूर से इस तरह से कि जैसे एक मंदिर के अंदर कोई भगवान की मूर्ति रखी हुई आकर के उनके दंडोत करते हैं, लेकिन उससे तादात्म्य या उससे अपनापन का बोध नहीं करते हैं। हम अपने वैज्ञानिकों का इतना अधिक कार्य हो रहा है जिसके कारण ये देश प्रगति कर रहा है, और आज हम उनके संबंध में अच्छी तरह से जानते नहीं। और जब हम जानते नहीं तो उनको सपोर्ट कैसे देंगे? देखिए, कोई भी संस्था, कोई भी केवल सरकारी माध्यम से ही संरक्षण देने से नहीं होगा। जब तक समाज उनको नहीं संभालेगा तो हमारी वैज्ञानिक प्रगति कैसे होगी? यह देश एक समय ज्ञान विज्ञान में इतना उन्नत था, हम क्यों पिछड़ गए? क्योंकि समाज ने विज्ञान के प्रति एक उदासीन दृष्टिकोण अपना लिया। लेकिन सौभाग्यवश, फॉर्चुनेटली फॉर लास्ट फ्यू ईयर्स, और कुछ महान चिंतकों के और कुछ नेताओं के प्रयास से भारतवर्ष में पुनः एक तरह से विज्ञान की क्रांति लाने के लिए प्रयास हो रहा है। लेकिन इस सब के अंदर केवल सरकार के करने से नहीं होगा, हम सबको साथ में मिलकर चलना पड़ेगा। अब सहयोग देने के लिए जब उनका जानेंगे नहीं तो आप सहयोग कहाँ से देंगे? तो भारतीय संस्कृति संसद और भारतीय विद्या मंदिर, इन दो पुरानी स्थापित संस्थाएं, संसद, भारतीय संस्कृति संसद तो 1955 में यहाँ पर एस्टेब्लिश हुई, और भारतीय विद्या मंदिर 1948 में राजस्थान के अंदर स्थापित हुआ। ये संस्थाएं संस्कृति के प्रति समर्पित थी, रही हैं। महान चिंतक, विचारक, कलाकार और कुछ कुछ वैज्ञानिक भी यहाँ पर आए हैं। लेकिन प्राय समाज जो है वो साहित्य और कला, आर्ट की तरफ में ही ज़्यादा ध्यान दे रहा था। हम कविताएं सुनते हैं, साहित्यकारों की बातें सुनते हैं, कलाकारों को सुनते हैं, एग्जीबिशन देखते हैं, लेकिन विज्ञान की बात बहुत कम करते हैं, परिवार में भी बहुत कम, या इकोनॉमिक्स या पॉलिटिक्स की बात करते हैं। तो फॉर्चुनेटली, सौभाग्य से मेरे मित्र डॉक्टर देवी प्रसाद दुआरी से एक संपर्क बना हुआ था। आप इसके अंदर डायरेक्टर रहे बिरला प्लेनेटेरियम के अंदर, वहाँ से तो रिटायर हो गए, लेकिन आज पूरे देश के अंदर घूम घूम करके और आप वैज्ञानिक की जो बातें हैं, ख़ास तौर से एस्ट्रोफिजिक्स की, वो बच्चों से लेकर बड़ों तक पहुंचा रहे हैं। तो हमारा ये प्रयास है उनकी प्रेरणा से कि इस प्रकार वैज्ञानिकों को के साथ के अंदर हम एक संबंध बना के रखें। अब मुश्किल क्या है कि अपने समाज से साधारणतया लोग विज्ञान की बात सुनने के लिए थोड़ा कष्ट नहीं उठाना चाहते। डॉक्टर अन्नपूर्णा जी जैसी विदुषी, जिन्होंने इतने वर्षों से तपस्या की है इस क्षेत्र के अंदर, अगर हम इस तपस्या को नहीं समझेंगे तो नुकसान, लॉस हमारा ही है। हाँ, एक बात जरूर है कि मैं वैज्ञानिक मित्रों से, बंधुओं से, उन विद्वानों को भी कहूँगा कि आप भी समाज के साथ में आएँ, मिलें। वैसे ये जाते हैं, अरे डॉक्टर अन्नपूर्णा जी कितना दुर्गा पूजा के ऑर्गेनाइज करती हैं, मैंने अभी सुना, और अद्भुत बातें बताती हैं। तो आज इनसे हम ग्लास एंड सिरेमिक रिसर्च इंस्टीट्यूट से, आप प्रमुख पदाधिकारी हैं वहाँ पर, इनसे हम ग्लास के संबंध में बात सुनेंगे। किसी दिन हम सिरेमिक्स की भी चर्चा करेंगे। और भाई हरिप्रसाद जी के संबंध में तो जितना कम कहा जाए, जितना ज़्यादा कहा जाए, जितना कहा जाए वो थोड़ा पड़ेगा। समाज के प्रति इनका समर्पण और इनकी एक एंटरप्राइजिंग दृष्टि, मैं केवल वो बिजनेस में नहीं है, ही इज एंटरप्रेनर, और एक वैज्ञानिक जैसी दृष्टि आपकी है। इन सब को पाकर मुझे बहुत खुशी हो रही है और मैं आप सबका बहुत बहुत स्वागत करता हूँ। अब मैं और आप सब ने पधार कर उत्साह बढ़ाया। आज अभी वातावरण कुछ ऐसा है कलकत्ते के अंदर कि लोग थोड़ा ट्रैवल कम कर रहे हैं, आते जाते कम है, इसलिए सभा के अंदर आज कुछ कम लोग हैं। पिछली दफ़े तो पूरा हॉल भर्ती था, बल्कि दूसरे कमरे में बैठ के देख रहे थे। तो मैं भाई पालीवाल जी से कहूँगा कि डॉक्टर अन्नपूर्णा का और अन्य हमारे जो डॉक्टर दुआरी जी का और हरिप्रसाद जी का सबका परिचय दें। और फिर उसके बाद के अंदर मैं डॉक्टर दुआरी से निवेदन करूँगा कि साइंस एंड सोसाइटी सिम्बायोसिस के संबंध में आपके विचार हमारे सामने रखें, और फिर हम डॉक्टर अन्नपूर्णा से सुनेंगे। और अंत में हरिप्रसाद जी की जो ज्ञान गर्भित बातें हैं वो भी सुनेंगे।
बहुत बहुत धन्यवाद हमारे अध्यक्ष महोदय का। मैं अपनी ओर से और संस्था के सभी सदस्यों और पदाधिकारियों की ओर से आपका इस अभिनव कार्यक्रम में अभिनंदन करता हूँ। आपको पता है कि हमारे जो आज के मुख्य वक्ता हैं वो हैं डॉक्टर के अन्नपूर्णा, जो एक बहुत ही विशिष्ट विषय पर आज व्याख्यान देंगी। और व्याख्यान का विषय है ग्लास, अ स्मार्ट एंड सस्टेनेबल मटेरियल फॉर बिल्डिंग्स। और संस्था ने ये जो कार्यक्रम हाथ में लिया है, इसके बारे में एक प्रस्तावना जो है वो हमारे दुआरी जी रखेंगे और आगे का कार्यक्रम भी वो जो मॉडरेशन है वो करेंगे। और हमारे आज के इस सत्र के अध्यक्ष बुधिया जी, उनसे हम उनका अध्यक्षीय वक्तव्य सुनेंगे। मेरा छोटा सा एक काम है हमारे आज के अतिथियों का परिचय देना। तो सबसे पहले हमारी आज की मुख्य वक्ता डॉक्टर अन्नपूर्णा is Scientist G and Chair Specialty Glass, CSIR CGCRI. She has obtained her PhD in physics in the year 1993 from Sri Venkateshwar University, Tirupati, followed by a postdoctoral fellowship from CSIR, and during her PhD, she worked on rare earth doped ZB-LAN and IB-LAN fluoride glasses. She joined CGCRI in the year 1996, and then she made significant contributions in the research and development of strategically important technology denied specialty glasses like ND laser glass, SM doped laser cavity material, filter glasses, optical glasses, infrared transmitting chalcogenide glasses for thermal imaging, including their pilot scale process technology towards Atmanirbhar Bharat. She has established architectural glass research and testing facility at CGCRI, which has been recognized as Testing Center for Bureau of Indian Standards. Her contributions in understanding the structure of property studies of rare earth, transition metal doped glasses, and transparent glass ceramics for photonics and energy applications are noteworthy in formulating novel glasses. She has around 170 plus publications in international journals of high repute, and 1 Indian and 6 international patents granted, and 2 are filed to her credit. She has guided 9 PhD students. She has also served as lab coordinator for the Academy of Scientific and Innovative Research, SIR, at CGCRI during 2015 to 2018. Dr. Annapurna is recipient of R.L. Thakur Award for Young Scientist in 1998 from Indian Ceramic Society. डॉक्टर अन्नपूर्णा, आपका बहुत बहुत स्वागत है इन दो संस्थाओं में, और आज के इस व्याख्यान सत्र की अध्यक्षता करेंगे हमारे अत्यंत समादृत उद्योगपति बुधिया जी. श्री हरिप्रसाद बुधिया जी इज़ चेयरमैन ऑफ पैटर्न इंटरनेशनल लिमिटेड. He is distinguished Indian industrialist and philanthropist, widely recognized for his transformative leadership in engineering and plastics, and for his enduring commitment to education in West Bengal. As chairman of Pattern International Limited, he has built the economy into a leading global manufacturer and exporter of steel stampings, EMT fittings, and plastic products including tanks and PVC pipes. Under his stewardship, Pattern has earned honors including the Z Business Company of the Year Award. In the field of philanthropy and education, he is associated with educational initiatives, including being a trustee of the Heritage Academy and other institutions. Contributing to social welfare, he is also the founder chairman of Swarnim International School, South 24 Parganas. Shri Budhiya ji is an active supporter of mental health and well-being through platforms like Caring Minds. He is the recipient of Lifetime Achievement Award in 2019 for his contribution to industry and society. Dare to Dream Award by Z Business for entrepreneurial vision. He was also nominated for Asia One Magazine's India's Greatest Brands and Leaders 2020-21. His career reflects a rare blend of industrial acumen and social responsibility with lasting impact across business and education. सर, आपका हार्दिक स्वागत है. और आज के हमारे मॉडरेटर हमारे प्रिय संस्था के सदस्य अग्रज डॉक्टर देवी प्रसाद दुआरी. He is one of the leading and most eminent astrophysicists and scientists of India. He is the director of research and academics, MP Birla Institute of Fundamental Research. Dr. Duari has traveled several countries to deliver lectures on astronomy and allied subjects. An alumnus of Jadavpur University, he completed his PhD from the renowned Inter-University Center for Astronomy and Astrophysics, under the guidance of leading scientist Professor Dr. Jayant Vishnu Narlikar. Dr. Duari is recipient of Gopal Chandra Bhattacharya Memorial Award for popularization of science in West Bengal in 2008, and he is a fellow of Royal Astronomical Society. Sir, आपका स्वागत है. और अब मैं आगे का जो संचालन है वो दुआरी जी को हैंड ओवर करता हूँ. मुझसे एक चूक हुई. हमारे जो आज के अतिथि हैं हम उन्हें अंगवस्त्र के द्वारा सम्मानित करेंगे, तो मैं संस्था के कोषाध्यक्ष सुशांत सुरेका से अनुरोध करूंगा कि वो सबसे पहले तो हमारी आज की जो मुख्य वक्ता हैं डॉक्टर के अन्नपूर्णा, उन्हें अंगवस्त्र देकर सम्मानित करें. अब मैं पुनः सुशांत से अनुरोध करूंगा कि वे हमारे आज के अध्यक्ष सम्माननीय हरिप्रसाद जी बुधिया जी को अंगवस्त्र देकर सम्मानित करें. धन्यवाद.
I waited 5 seconds to just say you good afternoon. It is just 12 o'clock. It's really an honor for me to be standing here today, taking part in this program. Our aim, vision and motto, as mentioned by Dr. Mundra, was to build up a synergy among the general people, scientific-minded personalities, and other personalities who think science is an object like a star in the sky, we cannot touch it. Because in our daily life, though we use in every aspect the applications of science, technology, but we fail to understand and recognize the importance. The importance not only from the point of view of pure knowledge, but the importance from the point of view of the future development. No country, no organization can progress without active support, recognition, and commendations of the general society and their members. So in that sense, science needs that. So I'm just reading out on my mind, yesterday whatever went through my mind. So the relationship between science, society, and development is interconnected. Each shapes and is shaped by the others. Understanding this triad helps explain how human civilization progress. Science is a systematic way of understanding the natural world through observation, experimentation, and reasoning. It produces knowledge that leads to innovation. It drives technological advancement and explains natural phenomena and encourages critical thinking. Whereas society provides the environment in which science operates and applied. So it determines the direction of scientific research. And obviously development is the interaction outcome of the interaction between these two. So it's an honor for me to talk about a very important aspect, science and society symbiosis. Because science, society, and development are the three pillars They are not isolated domains. Rather, as I mentioned, they're deeply interconnected, forming a dynamic and evolving relationship that shapes the destiny of civilizations. As mentioned, science is a systematic enterprise that builds and organizes knowledges in the form of testable explanations and predictions. Science has continuously expanded the boundaries of human understanding, perception, and consciousness. However, science does not exist in a vacuum. It is nurtured, guided, and sometimes restrained by the society. Society provides the context in which scientific inquiry takes place. The needs, aspirations, challenges of people influence the direction of research and innovation. So when science is effectively integrated into the fabric of the society, which is actually our focus of bharatiyavidyamandir and bharatiyasanskrit, through these series of lectures and awareness, the result is development. Developing the holistic improvement of well-being. Why I'm using these words? These are big sounding words. Basically, the pursuit of pure knowledge, the pursuit of pure happiness, the pursuit of that magic eureka moment when in your consciousness you realize that there are so many things which are interconnected which I never thought, because they are not written directly in any textbooks. That pursuit of purity probably is becoming a little weak, though we are progressing. So progress and the pursuit of pure knowledge, it seems they should be synonymous almost. But application of technology, application of scientific thoughts through technological development in our lives, that has taken over our everyday interests and inquisitiveness, not the science, not the pure knowledge that forms the foundation of those things. But today I have to say, last time it was jam-packed, the audience. Today I was doing a counting. There are 7 people who have come here. 6 of us are involved in this process. 3 officials who are also involved in this process, and 5 people who are supporting the progress of this particular meeting. Not a very encouraging word. This is not encouraging. It is difficult for me to accept that though we consider ourselves as scientific minded, though in our constitution it has been said that every Indian citizen should take up the responsibility of being scientifically tempered, after almost 80 years of independence, this should not be the scenario. But India is progressing in science and technology. That means what? That means there is a disconnect that is already happening, and hopefully not progressing but happening, between the society and science. That bridge should be brought together. And each one of you, I will expect, I'm not demanding, you should have spoken to the younger generation in your family, in your neighborhood, maybe in the place where you are employing them, to come on a Sunday morning. I understand. It's difficult. Or just before the biggest festival of Bengal, the election coming in. We are more interested in that, right? So it's a festival almost. Yeah, tomorrow is Akshaya Tritiya, I think. Okay. Yeah. So he made a very pertinent point, Akshaya Tritiya. There is nothing called science and culture now. Science is the culture. There is nothing called science and religion now. Science should be and is the religion. Right? Akshaya Tritiya is one of the festivals which is important. But science is holding us like mother for us to survive. It's much more bigger and important. I personally, this is very personal speaking, I'm not on behalf of the organization I'm speaking. Because in Bengali, dharm means whichever, amaki je dharon kore holds me. Science holds us, not only the scriptures. It is the consciousness, the ideas that holds us, not what is written. What is written should be understood and synthesized as pure knowledge. Science, similarly, is a pure knowledge base. So, I'm not countering you. What I'm trying to say is, let us rise up. Actively think how we can progress and increase this effort, mostly put forward by Dr. Mundra and the organization for the last 4 months almost, desperately trying to do. It's not only my stake. All of you are stakeholders. All of you, believe me. Your future generations will be benefited by the actions that you are taking now. So in that sense, we must cultivate a scientific temper, a spirit of inquiry, critical thinking, and openness to new ideas, which is very easy to say. Openness to new ideas, critical thinking. How many of us can support that? नहीं बाबा, जो चल रहा है ठीक ही है तो बाबा. Why make the difference and make a little consternation in our life or thoughts? That has to go, right? So it is the younger generation that will carry forward the legacy of scientific progress and shape the future of the society. Ceramics and glass. As I was discussing with, by the way, her full name is Professor Dr. Kalyan Durg Annapurna. I was supposed to introduce her, but it changed in the last evening or so, so I will not go into the details. Ceramics and glass are among the oldest material used by humans, and in India as well, much before Romans. Yet, they remain essential in modern life, ranging from daily household use to cutting-edge science and technology. Their importance, why they're important, lies in their versatility, durability, and unique physical properties. For example, ceramics, strength, heat resistance, innovation. They're inorganic, non-metallic materials typically made by heating natural minerals like clay. I was having a chat. Do you know ISRO nowadays and DRDO nowadays depends on ceramic coating and tiles for 2 things. When a satellite makes a re-entry, passing through the atmosphere, the temperature can rise up to 2000, 2500. In case of Artemis, it went up to 2600 degrees centigrade. Only a ceramic tile can stop the inside of the satellite not to be burned and to keep everybody safe and alive. Do you know the latest missile? India is one of the leading countries in the world in missile technology at present. The nose cone of a missile is coated by a ceramic metal, because the heat that will get generated moves in Mach 5 times sound velocity, 10 times sound velocity, 20 times. The heat will destroy it before it reaches the point. So ceramics are also used by that. Why ceramics matter? High resistance to heat and corrosion, excellent electrical insulation. You see high power 33 kilovolt lines. Those conductors, these things are all made up of ceramics. Long-lasting and environmental stable. I still have a mirror which was bought by my great-grandfather at our house, doing perfect job. Advanced ceramics are crucial in aerospace, nuclear reactors, and even space exploration. And key contribution, as I mentioned, daily life, construction, engineering application, medical field, electronics. Whereas glass is a non-crystalline, transparent material made mainly from sand, silica. Why glass matters? Most important, transparency. It allows light to pass through it. It is chemically inert. That's why a chemistry lab will have a series of bottles of chemicals in glass vials. And is safe for storage. Can be molded into various shapes, essential for modern communication systems. Architecture, communication, science, daily use, renewable energy. So together, ceramics and glass drive technological and social development. How? Infrastructure, healthcare, digital revolution, optical fibers, semiconductors, sustainability. However, innovation like bioceramics, have you heard about it? Probably she's just mentioned. She's one of the experts in the country. Smart glass and nanomaterials are opening new frontiers. So ceramics and glass are not just traditional materials, they are foundations of modern civilization. Ceramics provide strength and resilience. Glass offers clarity and connectivity. Together, they enable progress in science, make our lives much more productive, and have a happy feeling about life itself. About our speaker today, just one word. From our childhood, parents used to tell me, and later on in the school, we all know this. Vidya dadati vinayam. And vinayad yati patratam. Patravat dhanavapnoti dhanat dharmam tata sukham. She is an epitome of that. Nobody can say, looking at her humility, the amount of tremendous work, positive, innovative work. Think about a single person, PI as they are called, performing 69.8 crore rupee project of Government of India alone. She did it. That was not mentioned in her biodata, and this I think is one of the epitomes proof of what she is, technically, scientifically, and a brilliant mind. So let us all listen to her and try to understand, synthesize what her words and the meaning behind those words are going to tell us. Thank you.
नीचे कर सकते, थोड़ा नीचे कर सकते, मतलब ये थोड़ा ऊपर करना, हाँ बस। ये ठीक है। यहाँ थोड़ा सा बाद में मैं यहाँ आती हूँ। First of all, I am very much thankful to Dr. Diwari ji for a very kind introduction. And yeah, respected Dr. Mundra ji, Honorable President of today's function, Shri Budhiya ji, and distinguished Duwari ji and esteemed guests, very good afternoon. First of all, I would be thankful for inviting me to deliver this lecture. I am thankful to Dr. Mundra ji and also the organizers. Today I have selected a very generalized talk because here the audience will be not the true scientific people and they may not get interest in going into the technology. So I have touched in the glass, smart and sustainable material in buildings, because as Dr. Duwari ji has already, I have to thank him, he has already given the introduction of glass, which we see from our childhood. Whenever we see the material, we see glass will be all around, but we don't give attention to it. And this is the oldest material and highly engineered material. It is a very versatile material, means whatever you want you can make it. Mainly because it is not like a crystalline, but it is a non-crystalline. Any combination of material can give you the glass, and you can create any property whatever you want and for different applications. So that is the versatility it is having. So it can be a insulator, you can make it as a conductor by mixing the materials. So like that you can give a contradictory properties in it, and with very common application, common uses like a cutlery, like a tumbler, tableware, to very advanced applications. So I can just give you, and always the glass, the vast field of glass will come from science and technology to the art. Even you can see chandeliers or any flower vase, this comes with the art. So all three combination makes the glass full. So now I just go with the one small topic in glass. The glass is becoming as a sustainable and smart material in buildings. Earlier it used to be sitting only in the windows. Now the buildings have become total glass. So that just I wanted to give you a feeling how glass is working in the building, why it is working in the building, why it is smart. I just go through this, but before that I just wanted to introduce my institute where I work. My institute is CSIR, it is a CSIR institute, Scientific Council of Scientific and Industrial Research. We have a big organization under which we have 37 labs in India, and our lab is one among that. It is Central Glass and Ceramic Research Institute, which is situated in our just beside our Jadavpur University, and it has established in 1950. Earlier its foundation stone was laid pre-independence, but officially it has started in 1950 and it has taken, we have already completed 75 years. Just last year we have celebrated our platinum jubilee year. It has, the institute has incepted by the want of optical glass. During Second World War, the country wanted the optical glass. So optical glass means the glass, I just go after maybe few slides, I give what is the importance of glass. Optical glass is a strategic material, means all the instrument which are used in the strategic, like in defense, they require glass. So that is very important, even by aiming the missile or for anything, optical glass is very important. So the glass cannot be given by, the material is not been getting from any other country who was doing, and the technology was also not being given. So our people that time, Dr. Bhatnagar and other people, they thought we should have an institute where it should be dedicated to the glass, and they can develop the optical glasses needed to the country. So that way the institute has come, and Dr. Atmaram has been given to locate where it can be instituted. So he has chosen Kolkata as the place where the institute can be there. So he was the first founder director of our institute, Dr. Atmaram. And that time also, that was old generation optical glasses, 26 varieties our institute has developed, and that time the mandate was to characterize the raw materials and help ceramic and glass industries along with the development of optical glass, and also generation of HR and trained manpower in the allied field. That was the mandate of our institute, and still now also it is working in the same mandate with advanced material. So we have now 9 different divisions where it is the biomaterials and medical devices division, where we work on bioceramics and bioactive glass, where we can have implants. Body implants is made from ceramic, and the bioactive glass means you can have in the soft tissue or even load bearing also you can give, where the artificial appetite can be grown with the glass, so that the healing will be very fast, and it will not give any, it can be an antibacterial. So it give even the antibacterial and antivirus, so the healing will be very high. And another one is the advanced ceramics and composite division, where it is a non-oxide ceramics also we do. The radomes, the picture is given the radomes, what Dr. Duariji has told. The missile nose is made up of this silicon carbide nose. It is a very high temperature material which can go in 5 Mach or 7 Mach velocity also it can take. It has been made. And energy materials and devices division, it is they devoted to solid oxide fuel cell. It is a clean energy generation devices, like hydrogen is been the fuel and the energy is generated. And to generate hydrogen, again solid oxide electrolyzers also we do. So the hydrogen generation, and that is being utilized in solid oxide fuel cell to generate the energy. And another one is the functional materials and devices division, where the sensors have been made for even by breath, with the breath you can detect whether you have a diabetic or not. So such sensors have been developed. And then the gas sensors and pollution sensors we have developed. And another one is the multi-scale microstructure and mechanics of materials. They instituted all the characterization facility, and also they have some research activity. And then the membrane and separation technology division, where they make the ceramic membrane for gas separation, oil separation, oil purification, water purification they do. And then refractory and traditional ceramics. Here they work on traditional ceramics, refractories, where for the steel industry also they give the refractories. And then another one is the fiber optics and photonics division, which make the specialty fibers, which is for the amplifiers and high power laser things. And lastly the specialty glass division, I work here, and these two are with the glass, but they go with the fibers and we go with the bulk glass. I just give a glimpse of what the strategic material, strategic application having glasses, later I touch upon, but initially I do mention about the architectural glass. Before going that, we can say glass a gift from nature, because from ancient times glass is found in nature. How? As it is said, it is a non-crystalline material, means it is formed when a molten mass is solidified very fast. Means the time is not there to arrange in a systematic way. Means when you go, a crystalline material always has the molecular structure in an orderly way. The glass lacks it. Like in a liquid has no orderly structure. So the glass is having molecular structure like a liquid, but the form, the shape is like a solid. So it is again a unique material. So when a lava is fastly cooled, there you can found the glass. That is the natural glass. This is the natural glass. It is solidified from the lava. when the volcano is erupted, the lava is solidified and formed the glass. And then also in nature, when meteoritic bodies collide with the earth, the temperatures will be very high. During that time, when at the point of collision the material is liquefied, like it is melted, when it is cooled fast, the glass is formed. That glass is called meteoritic glass. And again you can see the lightning. When the lightning is coming, at that time, at that point of time also glass is formed. And the marine glass also, you can see the glass is formed. These are all natural glasses. And later man has also made, but by always man advances by seeing the nature. We always learn from the nature and we imitate the nature, and then we progress in the life and we become advanced. So later mankind has learned how the glass can be made. That is also accidental. It is when they were accidentally made, the temperature was like the sea sand, sea salt and the bones. When it was taken together and they exceeded the temperature, which an accident, the resulted material, they got the glass. So by that way they could see the glass can be made by man. So that is like silica, salt, like it is a soda, and the bone is the lime. So soda lime silicate glass, whatever you see on the windows, whatever the bottles, glass, tumblers, all are made up of soda lime silicate glass. So like that you have different containers you have made by blown method. So later, first it was used ancient in 3600 BCE. From then the glass was made by man. So that way it is existed by blowing, by molding. So it has advanced, and we can see the glass. First, the novel invention we can say is the glass window. So in the window it can give you the comfort, it can protect you from the harsh environment, and still you can get the natural light inside. And that is, and now it is not only taking place in the window, the entire building is becoming the glass. And then the optical glass, invention of optical glass, which has made to invent the microscope. That this simple microscope has given whole medical science. You cannot think today's medical science without microscope. So without glass there is no microscope. Only the microscope is able to make you to see the microorganism. So that is indispensable. And again the light bulb. So again without the light bulb enclosure you cannot have the light in our homes. And the one which is the glass fiber, the same optical glass also, where you can see the microorganisms. With the same optical glass, when you put it in the telescope, you can see the celestial bodies, the macro bodies. So there again the invisible things the glass is making you to see. So again the optical fiber, which is laid down across the continents, now it has revolutionized and made the society so fast. So the whole world is in our palm now. So with a single click you can see anything, everything. So that is possible only due to the glass fiber. Without the glass fiber we could not have been advanced in this. So the society has advanced with the glass. So with this, always the science is, every time it is going forward. With the science, the technology also developing. With the technology we are coming up with newer and newer varieties of glasses. Though initially there are sheet glass used to be prepared. When the sheet glass is used to be prepared, this is also a flat glass, but the molten mass is flown through the rollers. When you are flowing through the rollers, you may see there is some wrinkles, the flatness is little disturbed. You may not see with the normal eye, but when you see through such type of glasses, if you see in the old buildings, the glass window, if you can see, if you can see through the glass window, the outside pictures or the outside you see some distortion. The visibility was not very clear. It is only due to the non-uniform thickness inside and non-uniformity in the glass. Density is different and the thickness is different. That is why you see some distortion in the images when you see through it. But now the process, the glass making process has been changed. It is the float process we call that, where the molten glass, molten mass is flown onto the tin bath. This is the tin bath which is kept at 2000 degree in the reduced atmosphere, and on that, because the tin is very heavy and the glass molten mass is flown on it, so it will float. And when you give any float on any material, it becomes the uniform thickness. You don't need to polish, but naturally you can get the very uniform thickness, and the homogeneity also the technology has taken. The homogeneity, compositionally it is homogeneous. That is why you can see now very clear images you can see, and very big sheets you are able to make. So that is why now the buildings you are using many everywhere. Now you are replacing the walls, you are replacing the ceiling, you are replacing the floor, you are replacing the staircase with glass. And again, why glass is becoming smart and sustainable? So first thing, I make it just by the manufacturing. As such, glass is a very energy incentive material. To make the glass, you require more energy, and also because you are using the minerals, so the emissions, when you are melting them, the carbon dioxide may come out. Now, as because the world is going towards the zero carbon up to 2070, all the glass industry also going towards the carbon footprint, zero carbon towards. So that is why new energy efficient production processes are being invented, like with the raw materials where you have a carbon dioxide ingredients, you are replacing without carbon materials, and also you are making to heat the energy which is fuel that is going with the natural gas. Instead of that, all oil fired or gas fired, you are going towards the solar or wind energy, renewable energy. So that way you are making it energy efficient production, and it is 100% recyclable. Any glass after making, you can again take it and then you can melt it. Again you can make the useful product. This is the material which you can make it 100% recyclable. So you can make secondary products, and then it is a very highly durable, as Dr. Diwari ji told, it is non-reactive and the maintenance is minimum. And again you can make it security and safety. Safety glass or secured glass, you can make it resistance to human impact, you can make it fire resistant, and then resistant to forced entry or ballistic attack. Bullet resistant glasses you can make. And again it is energy efficiency by performance. That was I mentioned as a manufacturing. Now it can be a energy efficiency by performance. Why? How? Like it can, when you are using it in a window or in a whole wall, it can control the solar energy which is coming inside, so that you can reduce the energy consumption inside the building, in the home or in the building. So that way it is energy efficient. The key parameters that we normally see how it is energy efficient, we see visible light transmittance, U value and solar heat gain coefficient. These are the three parameters we see to judge that glass is energy efficient. So what is visible light transmission? It is the measure of the visible light transmitted through the glass. Like if it is the glass, it is the visible light is incidented, it is transmitted, and some it will be absorbed, and some will be reflected. The absorbed light, again it may reflect inside, like outside and inside. Totally all those things will come into the visible light transmission. U value. U value is nothing but heat transmittance through the glass by conduction, convection and radiation. And by definition, U value can be the heat transferred that is lost or gained due to the temperature difference of 1 Kelvin through 1 meter square. If this is the glass pane of 1 meter, if this side it is 0 degree and this side is 1 degree, this is the 1 degree difference, the heat transferred between this is the U value. And then solar heat gain coefficient is again a fraction of incident solar radiation admitted through the fenestration, like whole window, both directly transmitted and absorbed and again transmitted inside and outside. This is the solar heat gain coefficient. By judging these 3 parameters, we say glass is efficient, energy efficient or not. So it always, as I said, it always gives you the comfort, and it will be giving you, when you use most of the building the glass, you cannot lose the natural light inside, and that way you can cut down your electricity. And passive and temperature control means when you apply some coatings on the glass, coated glass we call it, in the colder regions the glass can harness solar heat gain, means it will make it, the heat is coming inside so that it keeps the room hotter. So you can consume less energy to heat the room. And in warmer climates like in India, the coatings will be such, it will keep the room colder than outside. So this all made by the coatings on the glass. So that way it is smarter. We are making the glass smarter. The similar way, we can make it in different designs. You can make different shapes, and that way you can make it whatever, in which shape you can have your building, it can give the aesthetic view. So the very appealing buildings, you visually appealing buildings you can have by just, you cannot make this as a concrete. You cannot do it with the concrete, only glass it can be made. And you can make the building acoustic insulation. Only with the glass you can make the building acoustically insulated, and again it is a cost effective. It can save the light, the costs. And then you can again manage the light, you can cut down the glare. And some glasses, you can make the glass with a click of a button, a transparent glass with a click of a button you can make a opaqueness. That all you can do in a single panel. Maybe it is here a double layer, within the 2 layers you will be having a material which can make it opaque. So in a office, a cabinet can be made a see-through. Whenever you have any meeting, you can make it as a opaque. So such a smartness you can bring it only when you have a glass in your, you are building the cabins with the glass. So I just make, these are all soda lime silicate, but where based on the manufacturing, based on the processing, and then with the different types, you have different types of glass. All are soda lime silicate glasses. I am just talking only soda lime silicate glasses today. And in that float glass, you can have 4 different, one is the clear, extra clear, tinted glass, coated glass, and one more is the sheet glass. And then with the float glass or sheet glass, you can have, based on process, you can have a toughened glass, you can have a laminated glass, heat strengthened glass, insulated glazing unit, and some other specialty glasses we call, that is fire resistant. We normally see, or it is our convention to think glass is a brittle material. You cannot have, for some applications you cannot have glass, but you can say glass is stronger than steel. You can make the glass is stronger than steel. I'm telling a steel expert, but I can say glass is stronger than steel if you avoid the micro cracks in it. So fire resistant, it can protect you from fire, how I will just tell you. And bullet resistant glass, and security glass and safety glass and pattern glass and others, you can call them as a specialty glasses. They are just float glass, means normally glass, I already told, when you melt the raw material like a powdered raw material, you take it to the high temperature, you make it as a liquid. When you are melting it, the material becomes liquid and you cool it very fast. We call that, technically it is quenching. That process is called quenching. Fast cooling is quenching. When you cool fast, it is not having time to arrange the atoms in an orderly way, so it becomes glass. But when you cool it to the room temperature, then when you are making, you are suddenly taking all the thermal energy, when you are cooling it, so some stress may form inside the glass. So if you cool it to the room temperature, the stress will be there in the material. So if you just touch it, it may break. So that becomes so brittle. So to avoid that, the glass process is, you just cool it to certain temperature, where that is called glass transition temperature. Don't cool it to the room temperature. Suppose in the soda lime silicate glass, you cool it to 600, from 1550 degree centigrade to 650 degree temperature, fast cooling, and then from there you just cool it slowly in a programmed way. That we call it as a annealing. Even in metals you do anneal, only to remove the stresses, the thermal stresses, residual stresses we call. Then the glass becomes stable. So if you do that, this is a normal annealed glass. It breaks in a bigger pieces and sharp cuts. That is normal float glass. It is a base glass, and these are the base glass. So this you can make safety glass and laminated glass. From this glass you make different types of glasses. So even to prove this is a float glass, for some, means everything, any material we have to have a testing, because it is a genuine material. So like that for the glass also we have, that I just tell what are the standards. And for the prove that glass is float glass, we have a standard IS 14900, is again BIS standard. We have to test whatever the standard says. According to those, the test, we have to subject the glass to that, and then we have to prove, like when you see the tin side, like I said, when you are making the float glass, you are passing or flowing the molten mass on tin bath. So that is why one side you will be having a very thin layer of tin. So if you get the tin on the glass, then that glass you may say this is the float glass. So that you test it by UV light. When you expose it to the glass, you will be getting a fluorescence, like it glows, it gives a light. So when you get that light, you say that glass is float glass. That is the conformity test. We do that. And then we have whether how many bubbles are there, means you have to have so many bubbles only there. Sometimes you should not have any bubbles. Some faults, like a streak, line cracks, like a bubble which elongates when it is in the process. All these you should avoid. So for all those we will be having certain mandated tests. You have to make all those tests to make that as a suitable float glass. Only then it comes into the market. So all these we have in the institute, and then in that float glass, that is a normal prepared glass, that is annealed glass, and later you in that again you have a clear glass, extra clear, tinted, coated. So based on the coating, when you go with the coated glass, online coating, offline coating, and again how based on the performance, you have a solar control glass and low emissivity glass. So when you go with clear glass, means it is just annealed glass, that is called clear glass. Just prepared glass, annealed glass is a clear glass which is having the transmission. You must have in the standard, you must have this is the thickness from 2 mm thick to 25 mm thick the industry prepares or produce. So, we must have the transmission percentage, you must have with the thickness, this must be the transmission. Then you make that as a clear, you can say that is as a clear glass. And this tinge which you are seeing, this is the green tinge, there is no colorant in it, but the green tinge is coming due to the iron present in it, which as a impurity. So, that is why if any glass, even in the window pane, if you see through its thickness like this, if you see through this, here you can see the green tinge. Extra clear glass, you have to remove, or the raw material which are being used to prepare this glass, you must avoid the iron impurity in it. When you make in a normal float glass, you may have 830 or 850 ppm, ppm is parts per million, that much iron may be present, that is allowed. But when you reduce the iron to 150 or 120 ppm, then the glass can transmit 92% and it can look like this. There is no green tinge you can see. Now, the modern buildings, whatever you can see, when you are, until you go near to a door or a window, you cannot realize there is a glass, because it is an extra clear glass. So, because there is no iron in it. So, there is a difference. You see, this is the clear glass and this is the extra clear glass. Little bit cost, it may be having a little costly, but still it is affordable now due to the technology advancement. And next comes the tinted glass. Tinted glass means the colored glass. Tinted means it is the body tinted, means you have wantedly given some colorants when you are making it. So, mainly the transition metals can be given inside to give whichever color we get. Different shades you can make by giving either a single transition metal or a rare or combination of transition metals, like amber color glass. This is a very common amber color glass, is the iron and carbon gives you the, and sulfur. Iron sulfide gives you the amber color, like nickel, cobalt, iron gives you the bronze, like different, cobalt gives you the blue, the chromium gives you the green. So, like that you will be having, within that you will be having different shades. So, these are all, again it depends on the patented and depends on the different industry. So, when you see this, this is seen from outside. When you see from outside the building, it may look like this. When you see from outside, inside, it can be seen like this. So, from outside you cannot see inside, but from inside you can see the outside. So, because of the coatings and the tint, the reflection will give you opaque, you cannot see through inside. So, that way you can make it. The coated glass, you have two methods. One is the offline, means after making the glass, you have cut and taking the big, maybe 2 meter by 2 meter by 3 meter by 2 meter or meter by 3 meter, you are coating it. It is offline. That maybe you can use different sputtering or different methods. You can make a thick coatings. That is one process. It can be done either by the manufacturer, glass manufacturer in their site, or by taking a normal glass. The processor can also be make in their site. And online coating means when you are making the glass, online itself, when you are manufacturing the glass, there itself the coating will be there. So, mainly the solar control glasses and all, they make like this. So, here only manufacturer will be doing this type of glass. And the based on functional performance, like the solar control glass, means solar control glass, here you can see the sunlight is coming and due to the coating made on the glass, it can it can cut down the heat enter into the room. It will be reflecting out, heat will be reflected out. The only light will go, but and UV light also will be reflected out. In this process, small portion of visible light may also go down, but it can control the solar radiation, like heat energy can be cut down. And low emissivity glass, again due to the coatings, it will be having a 2 panes, a double glazing unit. The coating will be inside the double glazing, and here again what I said, here the coating surface emittivity, it will be having again the thermal insulation it can give you. I mean totally it can cut down even whatever the very harsh and very severe hotness is there outside, but you feel very cold inside. So that way you can make it with the window, glass window. So another process is the toughened glass. This is the safety glass. So normally when we see, when it is made as made glass, float glass, when you have a bigger pieces will be broken or sharp edges will be coming. So that will hurt us. So when you are putting that in the building, if any accident happens, it without building falling, means if any glass comes and hurt a human being, only by that the man may leave his life. So to avoid that, you should avoid breaking the glass in sharp pieces. So for that we have to make a process where you heat the glass to glass transition temperature, just above glass, like 650 for soda lime silicate, you take it to the 650 degree centigrade and again cool it very fast. Means when you are cooling it, the surface will be cooled and there you are creating a compressive stress. So that way you make a compressive stress on the surface. If you make that, when you break or the glass is broken, it breaks in a very small pieces. This you may see in many buildings. Any glass which is accidentally broken, it just rubbles like this, means it just goes like a small very round, not a sharp edge but round edge glasses will be fallen. Whether you have seen or not, those are the safety glasses, mean that will not hurt. Even you can take it in the fist and you can press it, but it will not hurt. So when you toughen the glass, that property it will attain. It will break in the very small pieces and the edges will be not sharp. So this we can test it. We have to test when to declare that glass as a safety glass, we have to test. This test is called fragmentation test, and also we have to test its flatness. So because you are taking one more process as a toughened glass, you are again heating it and again you are cooling it. So in that you may make the glass to go on the roller, so its flatness may be disturbed. So you have to see its bend, bow, and then the roller waviness, edge lift, all these local distortions, because again it may be disturbing the visibility. So that is why we have to see how good it has been toughened. Again we have to test it through the ball drop test. So from 4 meters or 12 meters, you have to have a steel ball of 560 gram, you have to make it to fall on the glass from 4 meters or 12 meters. It is again two types of test, and glass should not break. So then that glass is passed. So that is the safety glass, means it is an impact resistant. You are pouring it as a impact resistance, and then you have to Next is the heat strengthened. These are the same process, but here the cooling will be little slower. It will also break, but not very fragmented, very small pieces, but it breaks in such a way all the breaks will go to the edges. It cannot be made as a safety glass, but the advantage of this, if the glass is fitted in the frame, these pieces will not fall. So, that is the safety that you can bring in. Here also we see all the testings, whether it is a heat strengthened or not. Another one is the laminated glass. Here the glass is laminated with a polymer sheet. So, when the glass is broken, it will not fall, but it will be stuck inside. You can see this in the all vehicles, automobile application, you can see all the glasses, even it is broken, it will not fall. That is due to the lamination. So, these are all the series of tests we have to subject the laminated glass, whether it is properly laminated or not. These are the conformity tests, otherwise it is not passed to go into the market. Here again we say the ball drop and also shot back. Shot back again human impact test, means in the laboratory we are testing it whether it is sustained the human impact. And next is the insulated glazing unit. Here you will be having two panes with the spacer, there is a gap between. This gap can be with the spacer. This gap can be a vacuum if it is a soundproof or acoustic insulation, or it can be a argon filled or dry air filled. It can be a thermal insulation. So, that is why you will be having very coldness, and when you are the very harsh environment is there outside also. This insulated glazing units you can see very commonly in the coaches, AC coaches in the rail, you see same things. It can be, it is made in this way. Two panes will be there. This is the toughened glass and it can be coated. Coated glass can be there. So, this is the laminated insulated glazing unit. So, this is it is also having different types of testings we have to do to make it as a whether properly done or not. Next is the very specialty glass, is the fire resistant glass. Means nowadays you can have fire accidents. So, sometimes because of it is not too much of fire, but only with the smoke the people may lose the life. So, to avoid that, and sometimes people cannot be taken out due to the radiation with the hotness. The people cannot come out, that is why they will be inside only and they will lose their life. To give that special advantage, you can use some type of glass where it can give you some time which the fire cannot encroach to the other portions. So, people can be evacuated within that time, then you can save the lives. So that type of glasses are the fire resistant glass. You have different types, like wired glass is inside it and you have two panes. It is a submerged fire resistant glass, and you can be intuminant glass. You will be having some type of a material when it is faced to the fire, that whatever may be the material inside, that becomes like a foam. So, that gives the resistant, and then it acts as a fire resistant. So, if you can see here, like this it is there, you have a material here like this. It normally it will be a transparent and it is a see-through, nothing you can see whether some material is there. When the fire is there inside, when it is subject or it is facing the fire, the inside material becomes like a foam, and that may, the front glass may broke, but this will resist the fire to come this side. So, that way it will be protecting the other side, which will not be, the fire will not be coming to this side. So, based on that, you have three different types of fire resistant glasses. One is integrity, means it will avoid fire to spread, but radiation it may pass. It is integrity, means it sustain the integrity, fire will not come inside, but radiation, you may feel very hot near the glass. Another one is radiation control, that it is indicated as EW, means 15 kilowatt per centimeter square meter at 1 meter, up to 1 meter it can resist to spread the heat. And another type is the insulation, it will not allow the fire to come, and at the same time it will not also totally, means even near the glass you feel no fire or no heat. So that is insulation. So three types of glasses, up to 120 minutes you just can resist the fire to come to the other side. So this type of things, if in the emergency exists and all, if you install the fire resistant glass, so through that you can evacuate the people, and in some doors you can have the fire resistant, and then you can see and you can resist the fire to come to this side. And bullet resistant glass will give you in the vehicles, you can have bullet resistant, and again it is having not a single pen, it will be having a multiple layers, the laminated, so bullet will not be impinging through this, it will arrest the momentum of the bullet, it will not come to the other side. So that way you can have the bullet resistant glass. Even all these will be coming in the buildings right now. So human entry you can resist, so you can have the glasses made to resist the human entry, forceful entry, and bullet resistant. And you can have a patterned glass, with on the glass you will be having a different designs on it, ceramic paint you can have, and when you are tempering it, when you are subjecting it to again a thermal treatment, the ceramic paint will be permanent. So that you can install on the building, on the wall, and on the other side you will be having a very glazing surface, but inside you will be having a pattern, design. So the maintenance will be very easy. So these are all advanced technologies now coming in the glass industry. So for all these I told little testings and all, the conformity testings and the mandatory testings, and now even Indian code of practice for glass and glazing is becoming very, very important. Earlier we were having only 1 or 2 standards, now we are having more than 40 standards in India by BIS. So even in National Building Code this has been introduced. In section 8 you have glass and glazing and structural design, all these been included in the National Building Code. It is now becoming a compulsory to practice in wherever you have to have the glass in the building. And Energy Conservation and Sustainable Building Code, ECSBC, in this also you have many Indian Code of Practices, Eukonivas Samhita and residential buildings, all these are now in practice in India. And we have so many Indian standards which are existing in it, and some are already becoming like a mandate. Whenever any product is going to come into the market, they have to have the certification from BIS. There are many codes, I am just showing the list, I am not going into the details. And when we have the standard is always a very must practice we have to have, which can give you the sustainability of a society. When you are following a standard means your society is going with a standard itself is a standard. So that way, and it can go for long. So when you have a standard, when to have it as in practice, practically when you want to follow it, you must have a testing centers. So when there is no testing center, BIS cannot make it as a mandate. Because we work very closely with BIS, our institute is also having a mandate to work with BIS to formulate the standards, especially for glass and ceramics. So we are one of the place almost in the east portion, east region of our country. It is the architectural glass research and testing. Our CGCRI is having this facility, and other places in IIT Madras, they have structural glass research and testing facility, and in CEPT University they have another testing center. In Gujarat Forensics Science University they have these centers, they have glass testing. But our center, we have all like float glass testing, energy efficient, and also structural performance testing. All together we have architectural glass testing and research center we have. And this we have established in association with the Glazing Society of India, and we have in phased ways we have established it, and now we are fully working. And just beside this, I just wanted to introduce some other specialty glasses which we do in the lab, the glasses which are strategically important. One is the radiation shielding window glass. There is echo, na? This is the glass containing almost 72% of lead inside. Its density is 5.2 gram per cc. Normal soda lime silicate glass, whichever I now mentioned, its density is 2.5, and this glass density is 5.2, and this is able to attenuate, it resists the high energy radiation, means any gamma radiation also it will arrest, it will not let it through it. So that is why this glass is used in the nuclear hot cells. In our country, in nuclear fission reactors, they whatever the reactions are happening, that area is called hot cell. The walls are made up of lead bricks. At some places they will be having windows. Normal glass cannot be used, so they make the windows by using these glasses, where it can make you to see inside, but it protects from the gamma radiation. So that technology has been developed by CGCRI, and I want to go through this. You have mouse? नहीं है? अच्छा ठीक है, okay. I just wanted to, okay, now another one is the neodymium doped laser glass for high energy, high power applications. Is again very highly strategic important. It is used in high energy, high power applications. Whatever the nuclear reactors we have fission, but when you go for the nuclear fusion, means the energy generation will be very high, but to initiate that you will be requiring any very high energy to initiate the nuclear reaction. So that is why you require the lasers to initiate the nuclear reaction. So these glasses are used for those. So this is that high power, high energy lasers are being made in RRCAT, DAE, Department of Atomic Energy. So they require these glasses. I think I should, yeah, please. Another one is the chalcogenetic glass for thermal imaging. These glasses are non-oxide glasses, no oxygen. Oxygen is an impurity here, and it can transmit. Normal glass cannot transmit the infrared transmission, but these glasses can go up to 16 micron. Means our body or any living being, they emit. Means when we are getting radiation, we have to maintain our temperature. So always any hot body always will be radiating. Mean heat will be living out. So that heat will be always between 8 micron to 12 micron. Means with that heat we can locate any body, so any living being. So that way these glasses are used in the thermal imaging. Yeah. Another one is the optical glass. So this is the ISRO project. We have developed 5 varieties of optical glasses for space grade optical glasses, and which are, I explain it little later. Another one is the transparent glass ceramic for armor application, and we have also technology transfer we have done for few, like foam bricks, and also the nuclear the glass beads, not normal glass beads. These are used to store or to vitrify the nuclear waste. Any nuclear program, any country is having a nuclear program, the waste generated in the nuclear reaction cannot be thrown out. That becomes again a nuclear, very, very harmful. So you have to store it in a proper way and then dispose. So the glass is being used to dispose the nuclear waste. And I think this is the radiation shielding in window glass, and these are the explanation. This is the I skip some little explanations I have given. I don't think I don't need to give. I have already mentioned, and these are very, because of their strategic nature. They are very closely guarded technologies. The product, the material also cannot be given by anyone. So we have to make it. So our institute is involved, and we have made it up to the desired. And this is the thermal images. It is not only the strategic importance, not in the border surveillance or the human detection, but it can be used in agriculture, medical applications, and even online production line also. Thermal imaging cameras can be used. High power electric tension, electric installations, they use it to locate any hotspot. Before breakdown, the hotspots is generated. So with this thermal imaging cameras, they see whether the temperature is maintained or it is raising. So they take the precaution. So that way they have civilian applications also, and these are the thermal imaging made using our glass, and this is the space applications. So just to give you an idea, we call optical glass a crown glass and a flint glass. Means just the dispersion will be very low in crown glass, and the dispersion means the splitting of white light will be high in flint glass. If in any camera or in any imaging system, if you give only single component, a single glass, even in a convex or concave, whatever the lens, you cannot make the image proper. You can see different colors, but if you have a combination of crown and flint, you can have a very proper image. So just a general knowledge. And now I am done. I am giving the acknowledgement. I just want to stop my talk with the saying, throughout history, material have transformed the society in each and our culture. Like in Stone Age, stone was the proper, like tools and all, we have used stone. Bronze Age, Iron Age. So each age is mentioned or nomenclatured by the material. Now presently I can proudly say it is a glass age. Thank you very much.
It's a wonderful talk, because all of you realize that she started with the basic understanding of glass, its application, how the process of glass making has gone from evolution through scientific and technological advancement, and especially the last 5-10 minutes was amazing, because the potential of research and new innovation in glass and ceramics, how it is going to reshape the ecosystem of our development of our products. The hint is amazing. So next, I think we are all eager to learn and listen from our chief guest, Bharatiyavidyamandir, who will give his concepts, his ideas, and remarks and comments, which will definitely enrich
Firstly, I would like to thank Mr. Mundra and Bharatiya Sanskrithi Sansad, who has given this opportunity to me to get knowledge about the glass. I must say, from A to Z about the glass, origination to the present use and the future prospects. Everything has been in detail explained by her, so much that it's an exhaustive knowledge and to be used in every sphere wherever we like to use the glass. अब मुंद्रा जी जब पूरा ग्लास का मकान बनाएंगे, टोटल ग्लास, तब अपने को प्रैक्टिकल में देखने को मिलेगा. So let us wait for that, and I must thank ma'am that so exhaustive, I say, the first time I got the opportunity that on any subject so much of detailed knowledge can be imparted. अभी अपने बहुत ज्ञान की बातें सुनी है, और ये मेरा तो कोई सब्जेक्ट भी नहीं है. ये द्वारी जी हैं, या मान लीजिए इन्होंने, मैडम ने जितना नॉलेज और जितना इसके बारे में स्टडी किया हुआ है वो अपने को इम्पार्ट किया है. इसमें से जो कुछ भी ग्रहण कर सकते हैं वो अपने को ज़रूर सीखना और देखना चाहिए. मतलब की बात एक ही है कि साइंस एंड टेक्नोलॉजी, दैट इज़ द वास्ट सब्जेक्ट जिसके अंदर में सब कुछ आता है. तो साइंस और टेक्नोलॉजी हर फील्ड में हर जगह यूज़ की जाती है और करनी चाहिए. यदि कोई भी चीज़ के बारे में कोई विचार आता है, थॉट आता है, फिर तभी तो उसको डेवलप किया जा सकता है. और साइंस यदि अपने सोचें और उसको इम्प्लीमेंट करें तभी टेक्नोलॉजी डेवलप होती है. अभी द्वारी जी तो हमारे स्कूल में भी, एक स्कूल है हमारी स्वर्णिम बोल के, तो उसमें भी वी हैपन टू इनवाइट हिम, और वहाँ पे जब इनको सुना और देखा तो बाद में सब ने रिक्वेस्ट किया कि द्वारी जी को रिक्वेस्ट कीजिए कि वो अपने से जुड़ जाएं. एंड ही वाज गुड अनफ टू एक्सेप्ट दैट, एंड टुमारो इटसेल्फ अपने स्कूल में जाएंगे और बच्चों को, यंग माइंड्स को ही विल बी एनकरेज एंड मोटिवेट. क्योंकि ये सब्जेक्ट देखिए इतना टेक्निकल है और इसके बारे में अपने इतना सुना है और समझे हैं, तो आई डोंट वांट टू, और आई डोंट हैव एनी वर्ड इवन टू स्पीक अबाउट इट. मेरा क्षेत्र ज़्यादा रहा है एजुकेशन में. जैसे स्कूलें वगैरह भी हम लोगों ने खुद की भी बनवाई हुई है. राजस्थान में भी काफ़ी स्कूलें हैं अपनी, 4 या 5 स्कूल है. और यहाँ पर भी अभी जो नई स्कूल बनी है, एक बच्चे से चालू किया था. उस टाइम में 1 स्टूडेंट एंड 3 टीचर्स, क्योंकि टीचर तो रखने पड़ेंगे. और आज 10 साल कंप्लीट हुए हैं. कल ही हम लोगों ने फंक्शन किया था, तो उसमें 1058 स्टूडेंट्स हैं और रिजल्ट जो है वो 99% तक स्टूडेंट्स लाए हैं. तो यानी शिक्षा के क्षेत्र में इतना है कुछ करने के लिए. तो हम तो लास्ट टाइम जब सीएम यहाँ पे आए हुए थे राजस्थान के, तो सब्जेक्ट था इन्वेस्टमेंट. तो मैंने कहा जी मेरा इन्वेस्टमेंट तो एजुकेशन पर है. एजुकेशन का इन्वेस्टमेंट जो है वो अपने आप फलीभूत होता है. और जैसे इन्होंने बताया अभी विद्या ददाति विनयम, तो मैंने कहा वहीं से चालू होने से बाकी की चीज़ें अपने आप डेवलप होती है. और आगे जाके बच्चे ही हैं, वही मान लीजिए इंडिया में देखा जाए तो कंपैरेटिवली वर्ल्ड में कोई ऐसी जगह नहीं है जहाँ की इंडिया उनसे सुपीरियर नहीं हो. आज अमेरिका में भी जितने भी टेक्नोलॉजीज़ हैं जो डेवलप हुई है, करने वाले कौन हैं? अपने इंडियंस हैं. तो कहने का मतलब टेक्नोलॉजी में अपने पीछे नहीं है, परंतु यही है कि उसको इनक्रेज नहीं किया गया. लोगों का इंटरेस्ट इतना नहीं बन पाया था. बट नाउ पीपल हैव स्टार्टेड टू एंश्योर एंड फील अबाउट कि भाई ये एक सब्जेक्ट है, अनटच्ड है, इसको और अपने ये कर सकते हैं। अभी देखिए स्पेस में जितना किया है तो इंडिया पीछे नहीं रहा, उल्टा सबसे आगे ही रहा है कि स्पेस में भी इतना अपने अचीव कर पाए हैं। हर क्षेत्र में मैं तो यही कहूँगा कि इंडियंस का कोई बराबरी नहीं है। और आगे जाकर अब यदि अपने इसको भी लेने चालू कर दिए हैं, साइंस एंड टेक्नोलॉजी को भी ध्यान देना चालू कर दिया है, तो इंडिया का जो आत्मनिर्भर का अपने पीएम का स्लोगन है या मान लीजिए इच्छा है उनकी, तो वो भी डेफिनेटली अपने जल्दी से जल्दी अचीव कर पाएंगे। मैं सबको बहुत धन्यवाद देता हूँ कि मेरे को ये अपॉर्चुनिटी थी, और मुंदड़ा जी का नया मकान देखने की हमारी इच्छा रहेगी कि वो टोटल क्लास का मकान बने। द्वारी जी और मैडम का तो कुछ मेरे पास बोलने के लिए शब्द ही नहीं है कि जितना एग्जॉस्टिव इन्होंने ज्ञान अपने को दिया है, अपने उसमें से थोड़ा बहुत भी कुछ सीख सकेंगे तो दैट विल बी ए बेनिफिट टू अस। थैंक यू वेरी वेरी मच टू एवरी वन ऑफ यू।
मैं आप सबको धन्यवाद देना चाहता हूँ। मैडम अन्नपूर्णा जी को, हमारे बुधिया जी को, डॉक्टर दुआरी जी को मैं प्रणाम भी हमारी संस्था की तरफ से करता हूँ। इनका स्नेह हमारे ऊपर, स्पेशली डॉक्टर दुआरी जी का स्नेह हमारे ऊपर बना रहता है। डॉक्टर बुधिया जी भी हमारे संसद से जुड़े हैं और मैं आशा करता हूँ आगे फिर भी वो जुड़े हुए ही रहेंगे। मैडम ने आज इतनी अच्छी तरह कहा, बिल्कुल मैं मानता हूँ कि 1.25 घंटे का लेक्चर था। नॉर्मली यहाँ इतने लेक्चर होते हैं 45 मिनट के बाद लोग अगल बगल देखने लगते हैं, लेकिन इनके वे ऑफ प्रेजेंटेशन था टेक्निकल, लेकिन वे ऑफ प्रेजेंटेशन में भाषा और शब्दों को इस तरह से कहा कि हम लोग सब बंधे रह गए, पता नहीं चला कि, और ये नहीं था कि कब ख़त्म हो। ऐसा होता है अक्सर। क्या होता है, समय जब अधिक हो जाता है तो लोग ये सोचते हैं चलो भाई कब ख़त्म करें कब, लेकिन बिल्कुल भी ऐसा नहीं था। और इतनी अच्छी बातें और इतनी नई बातें हमको सुनने को मिली, और इनका वे ऑफ जो प्रेजेंटेशन था अद्भुत था। मैं उन्हें पुनः प्रणाम निवेदन करता हूँ। आप सब आए, बहुत ही अच्छा लगा। लेकिन हाँ, एक बात जो द्वारी जी ने कही कि हमें अधिक से अधिक जुड़ना होगा। देखिए, विज्ञान के बारे में जब अपने को जानकारी नहीं होगी, आज से अगर आप 50 साल पहले भी देखेंगे तो हमारे घर में जो हमारे बड़े बुजुर्ग थे, सबको छोटी मोटी दवाई वगैरह का पूरा टेक्निकल नॉलेज था। हाथ में इंजेक्शन ले लेते थे, हाथ में ये कर लेते, किसको कैसे सफ़ा करना क्या। अब क्या है कि अपने लोगों को इतना ज़्यादा अपने डिपेंडेंट हो गए हैं कि कैलकुलेशन भी अपने मशीन में करते हैं। अगर मैं अपने स्टाफ को ही बोलूँगा कि भाई 4 अंकों का अगर जोड़ भी देना है, सर 80 कैलकुलेशन नहीं, मतलब इस तरह की स्थिति हो गई है। तो एनीवे, हमारी संस्था की तरफ से मुंद्रा जी का इतना सुंदर विचार है और इतने अच्छी तरह वो इम्प्लीमेंट कर रहे हैं। अब ज़रूरत है हमें रिस्पॉन्ड करने की, हम अधिक से अधिक आएँ। जो वक्ता हैं उनका भी उत्साह बढ़ता है, हमारा भी उत्साह बढ़ता है, और हम इसको आगे कर सकते। देखिए, लोग नहीं आते हैं तो दो बात होती है। एक तो जो वक्ता हैं उनको इतना फ़र्क नहीं पड़ता है, क्योंकि वो रात दिन देखते हैं और वो डेडिकेशन है कि वो हम अपनी बातें कहें। फ़र्क हम ही को पड़ता है कि हम उनकी बातों से वंचित रह जाते हैं, क्योंकि उनको कोई फ़र्क नहीं पड़ता। आप सुनने आए, 10 जन आए, 20 जन आए, 100 जन आए, लेकिन क्यों, उनको तो अपना ज्ञान है ही, उनके क्या फ़र्क पड़ेगा। अपने को चाहिए कि अपने अधिक से अधिक आएँ, सुने। और मेरा आप लोगों से यही निवेदन है कि अब कुछ अल्पाहार भोजन करके फिर जाएं। धन्यवाद।